First, what we want to do here is, of course, write our name out of our compound. Going back to our naming rules, and like I told you before, the naming stuff doesn't go away, so you need to keep practicing it. We'll throw things in there. You'll need to be doing this for the rest of the year. So I have KNO3. So what does K tell me about the name? It's potassium. Very good. Does potassium ever need a Roman numeral? No, because it's in group 1. It's an alkali metal, and it's not a MOM, not a multiple oxidation metal, because it only goes to a +1 charge. So we just write the name potassium here. Now, what is NO3? It's one of the somethings. Which one? Is it nitrite, nitrate? Which one? It's the A to E one, nitrate. NO3 -1, okay? Nitrate. Okay, so now with regular percents from math. Same idea here. Regular percents from math is this generalized equation of the part over the whole times 100 gives you the percent, correct? Everybody remembers this from math? The part over the whole times 100 gives you the percent. We're doing the same thing here, except for we're applying it to the elements in the compound. We want to know what percentage of the mass comes from a particular element. But before you can figure that out, you need to have the molar mass of the compound. So that's step 1, is to find the molar mass of the compound. So we'll do that here. We'll go K. What is K's molar mass? Off the periodic table, it's 39.10. Okay, then we have nitrogen. What's nitrogen's mass? That would be 14.01. Remember, we're doing all of our masses to the hundredth, which is 2 place values to the right. So you need to round to 2 place values to the right. And then oxygen. However, oxygen has 3 atoms in it, in the compound. So we're going to multiply oxygens by 3. So O equals 3 times the 16.00, which gives us 48.00, if you calculate that in your calculator. So now you take these 3 values, add them up to get your molar mass of the entire compound. So what does that come out to being? 39.10 plus 14.01 plus the 48.00 gives us 101.11 grams per mole. That's the first step, finding the molar mass. Now all I have to do now is take the part, like potassium's mass, divide it by the whole, which would be the entire compound's mass, times 100. So I'm going to go ahead and divide this by the entire compound's mass, then multiply by 100, and I will get the percent of the compound that comes from the mass of potassium. And that ends up being 38.7%. If I want to find the percentage that comes from nitrogen, I just take my 1401 and divide it by the entire mass of the compound, multiply by 100, and that should give me a smaller percentage, obviously, because nitrogen's mass is smaller. Does everybody see that? So this one ends up being 13.9%. And then last but not least, I will do the same for my oxygen here. Oxygen would be 101.11 times 100, and my percentage there obviously will be the largest amount because the highest mass of the compound comes from the oxygen, and it's 47.5%. Okay? So you're going to go through and you're going to name them. You might have to pull out your polyatomic sheet or pull out some of your naming rules again, the flow chart if need be. One of the names here, I'm sure you remember from biology. What's C6H12O6?
Glucose.
It is glucose, so I kind of threw that one in for fun. That's glucose. It's not a regular name, but it is a good compound to work with. Okay. And then the other one here that I would like to show you, just to do the beginning steps on, is over here for number 9. Because we have the parentheses in there, and I want to make sure you know how to do the parentheses for figuring out the number of atoms. Okay? So, number 9, what would number 9's name be here? What is Al? Aluminum. Good. And does aluminum ever get a Roman numeral? Is it a MOM, a multiple oxidation metal? It is not, so it's just not going to get a Roman numeral. How about SO4? What's that guy? Sulfate. Good, sulfate. Very good. Aluminum sulfate. Now, for counting our atoms here, we have Al. How many atoms of the Al? So you're going to do 2 times its mass, which is 26.98. 26.98, and you're going to get that value. But let's look at the S and the O, because this gets a little confusing. So for S, how do I figure out the number of atoms for S? So, yes, we're going to look at the parentheses, and this is an understood 1 here, right? Understood 1 subscript. What do I do in math when I have parentheses? Distribute or multiply, right? So this 3 multiplies by that 1, so we have a total of 3 atoms of sulfur. So that's at 32.06 each. Now for the oxygens, how would you figure out the oxygen amount? Distribute that 3 again. 3 times 4 gives me how many oxygens? 3 times 4 gives me 12 oxygens, and they're all worth 16.00 each. So when you have parentheses, make sure you distribute to the other atoms subscript by multiplying. Then you can add that one up and do the percents from there. So go ahead and work some of those problems. Are there any questions?